Hello, everybody. I hope everybody is doing fine. So, this is me, and I welcome you here in lecture number 6 of Light. Okay, so let's start this lecture without wasting our time. Let's begin. Okay, so here we are. So, in this slide, we will study about the image formation by convex lens. In the previous lecture, we saw the image formation by the concave lens. So here also the situation or the method is same. Okay, because we had discussed the ray diagrams, how to form ray diagrams. So by the help of those ray diagrams, we can simply make the image formation by convex lens. So let's begin. So this is a convex lens, and why it is a convex lens? Because you can see there are two surfaces, two convex surfaces here. Okay, and the other thing is because it is a converging lens. Why it is a converging lens? Because it converges lights. You can see it is it is converging light at this point, or you can say it is collecting light at this point. So that's why this is known as a converging mirror. Now, this is our first case. So let's suppose this is the position of the object. This is the position of the object, and we had placed the object at infinite distance from the lens. Okay, so here I am writing at infinite. And infinite means it is far away from this convex lens. Now we have to figure out what is the position of image. So in this case, we will draw a diagram. So here you can see this is a ray which is coming parallel to this principal axis. This is our principal axis. Let me write it here for you. Principal axis. Okay. So this ray is coming parallel, and after the refraction, it is meeting at this point F2. Okay, and this is another ray, and after the refraction, it also meets at this point F2. This is also a ray, this is also meeting F2. So simply means all the rays are meeting at this point F2. So what will be the position of image? So when we discuss concave mirror, I told you that where the images meets, sorry, where the rays meets, the image is formed at that point. So here the image is meeting at F2. So that's why our image will form at F2. Okay. I hope you got my point. Now guys, let's talk about the size of the image. So in this picture, you can clearly see that the size of the image is very small. Okay, it's very small. So for small sizes, we write diminished. And in this case, this is highly diminished image. Highly diminished means very small. And we can say it is point size. We can say it is point size. I hope you got my point. Now, we will try to understand the nature of the image. We will try to understand the nature of the image. So, to understand the nature, what we will do, it is very simple thing to answer. Why? Because I told you that if a ray actually meets with another ray, or you can say the point where image is forming, then you can check whether the rays are actually meeting or not. If they are actually meeting, it means the nature of the image is real, and real images are always inverted. Real images are always inverted. But let's suppose had it been the image where rays appears to be meeting. They are not actually meeting. So in that case, our image would have been virtual and erect. But in this case, in this particular case, where our image is formed by the actual meeting of rays, so in this case, the nature of the image would be real and inverted. I hope you got my point. Let me highlight it for you: real and inverted. Okay. I hope, guys, this first case might have been clear to you. Now we will move ahead to the second case. So here we are. This is the second case of convex lens. This is the second case of convex lens. In first case, what we had done, we had placed the object at infinite distance. But in this case, we will bring this object a little bit closer to this convex lens. You can see it is a little bit closer. So we can say that the position of the object beyond 2f1, beyond 2f1, you can see it is beyond 2f1 or C. Okay. Now we have to figure out what is the position of the image in this case. So again, we will do the same thing which we have been doing since very first lecture. We will simply draw its ray diagram, and by the help of this ray diagram, we can easily figure out the position of the image and all the terms which we need. So let's suppose this is our object and this is the ray. Let me change the pen. So this is the ray which is coming parallel to the principal axis. And the ray which goes parallel to the principal axis always pass through the focus. So this will pass through the focus. Okay. And this is another ray which is passing through the optical center. And when we were discussing about the ray diagrams, in the case of convex lens, then I told you that the ray which pass through the optical center doesn't change its path. It follows the same path without any deflection. So you can see there is no deviation from its path. It is simply following its path. And at this point, they are meeting. This is the point they are meeting. Okay. So now, if you are asked what is the position of the image in this case, then you can simply say that in this case, the position of the image is between f2 and 2f2. Between f2 and 2f2. Okay. I hope, guys, you understand this point. Now, let's talk about the size of the image. Let's talk about the size of the image. So you can say by looking at this picture that the object is larger than the image. This is your image, this is your object, and object appears to be larger to this image. So it simply means that here in this case, the image is smaller than the object, is smaller than the object. But I have written this for your simplicity, for your understanding. If you write and if you are asked what is the size of the image in this case, then you will write that the size of the image is diminished. Okay, you will not write smaller, you will write diminished. Now, after understanding this, let's talk about the nature of the image. So, what is the nature of the image in this case? So, guys, as you can see, the rays are actually meeting at this point. So, that's why the type of the image or the nature of the image is real, and real images are always inverted. Real images are what? Are always inverted. I hope you got my point. So let me highlight it. Okay. So I hope guys you got my point and you completely understand this second case. Let me again explain you for your basic understanding. So this is our object. This had been placed beyond to F1 and this is array, and to obtain its position of the image, what we have done, we had made a ray. This is a ray going parallel to this principal axis, and after the refraction it is passing through this F2, and this is another ray which is passing through this optical center, and this is the point where they are appearing to be meeting. And in this case we will say that the image is formed between F2 and 2F2. Now, if I talk about the size, then here in this case, the size is diminished. And if I talk about the nature, then the nature is simply real and inverted. Now, let's move on to the next slide and let's try to understand the third case of image formation by convex lens. So, this is a third case of image formation by convex lens. Okay. So, in this case, what we had done, we had actually placed the object at 2F1 and we brought it a little bit more closer to the convex lens. This is very closer to this convex lens as compared to the two previous cases which we have discussed yet. So this is at 2F1. So the position of the object is at 2F1. Now, we have to figure out the position of the image. Now, how can we do that? We can simply make its ray diagram. So, let's suppose this is a ray which is going parallel to this principal axis. This is a principal axis. Principal axis. Okay, and this is a ray which is going parallel to this principal axis. Now after the refraction we all know that whenever a ray goes parallel to the principal axis it passes through F2, so this will pass through F2. Okay, and this is another ray which is passing through the optical center, and whenever a ray passes through the optical center always follows its path and it always passes without any deviation. So this is the point where they are meeting, where they are meeting. So now you tell me that by looking at this picture, we can simply say that the image is forming at 2F2. The image is formed at 2F2. So the position of the image is at 2F2. Now, let's talk about the size of the image. So you can simply say by looking at this picture that the size of the image is same as of the object. Okay. If the height of the object is h, then the size of the image will also be h. It is the same size. So if you are asked what is the size in this case, then you will simply write same as of the object. Okay. Now let's talk about the nature. So nature is again same. Okay, because the rays are actually meeting. I don't need to explain you again and again the same thing. It is not rocket science. You can simply say that the rays are actually meeting. That's why the nature is real and inverted. And this is very important case because you can see that the size of the size of the object is same as of the image, or you can say the size of the image is same that of the object. Now after understanding this case, let's move on to the next slide and let's try to understand what is there for us. Okay, so here in this slide we will discuss about image formation by convex lens, which we have been doing since the very first time. But this is the case number fourth. This is the case number fourth. Now, what we had done in this case, as the other cases, we have been bringing closer to the objects. So, the same thing we did with it, we had placed the object more closer, and now in this case we had placed the object between two f1. I will write it here for you, between two f1 and f1. Okay, between two f1 and f1. Now in this case what would happen, where our image will form. So to figure out this, we will simply draw a ray diagram. So this is a ray which is going parallel to this principal axis, and after the refraction it is passing through this point f2. Okay, and it is going like this, because we know this when we saw ray diagrams, that whenever a ray comes parallel to the principal axis, always pass through the point f2. Now this is another ray which is passing through the optical center, and a ray which passes through the optical center always follows its path. So it will meet at this point. Let's suppose they are meeting at this point. So now you tell me what is the position of the image. So here the position of the image is beyond 2f2 or C2. Okay, so here in this case, the position of the image is beyond 2f2, or 2f2 is also, or can also be written C2. So that's why it is beyond C2 or 2f2, both are correct. Now, let's talk about the size. So here in this case, you can say that the size is enlarged. The size is enlarged, and why the size is enlarged? Because you can simply see it in this image, in this picture, that the object size is smaller than the image size. That's why the image form is enlarged, or image form is larger than the object. Now again, let's talk about nature. So now you tell me what is the nature. So here in this case, the nature of the image is real and inverted. Okay, real and inverted. Okay, and I again let you know that real images are always inverted. And don't get confused that I'm I'm not explaining you why it is inverted, because I already explained you in the previous lectures that why real images are always inverted and why virtual images are always erect. And you can also see it in this picture also. Okay, here you can see the image is upright. Sorry, the object is upright, but the image is just inverted. This A goes here and this B goes here. So that's why the image is inverted. Now let's move on to the next slide, and let's discuss the case number fifth. So this is the case number fifth. Okay. So now what we had done in this case, we had placed the object at F1. We had placed the objects at F1 here. Now let me write it here for you at F1. Now we have to determine what is the position of image. So we will again draw a ray diagram. This is a ray coming parallel to the principal axis. After refraction passing through the F2, this is another ray passing through the optical center, and they will, without deviation, it will follow its path. So now these rays will meet at infinite. These rays will meet at infinite. They will actually meet. So that's why in this case, the position of the image is at infinite. Now talk about the size. The size in this case is very, very large. So for the large sizes, we can simply write highly enlarged, highly enlarged. Now, let's talk about the nature. So I told you that the rays will actually meet here, okay, at very, larger distance. That's why we are writing that it will meet at infinite point. So they will definitely meet, they are going to meet. So that's why in this case the nature is also real and inverted, real and inverted. Okay, I hope you got my point. Let me highlight it for you. Now let's move on to the next slide and let's discuss the last case of the convex lens. It is very, 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 very important case. Okay. So now what happens in the previous cases, we have been bringing the object closer to the mirror. So this is the last case. In the previous case, we had placed the object at F1 in the case number 5th. So in this case, we will bring it more closer and we will place it between F1 and O. So what is the position of the object between F1 and O? O is optical center. So what will happen? This is a ray which is passing through the optical center O, and it will simply follows its path, and it will not show any deviation. Now this is another ray which is coming parallel to the principal axis and passing through this point F2. Now you can see that these rays are going in different direction. This is a ray F2 going in different direction. This is another ray going in different direction. Then how can they meet? They are not going to meet because their directions are different. So what can we do to make it meet? We have to move it, or we have to increase it in the previous direction. So if I draw this line, and if I increase in this direction, and if in this ray also if I increase it here, then at this point they appear to meet. At this point they appear to be meeting. So this is the point where the rays are appearing to be meeting. That's why our image is formed here. So if you are asked where will your image be formed, then you will simply say beyond 2f1, beyond 2f1. Okay, and now what is the size in this case? So you can see that the size is very, very larger, or you can say highly enlarged, highly enlarged. Okay, now let's talk about the nature. So here you need to be very, very careful while writing the nature, because in the last of the cases we had been writing real and inverted. If we have been asked what is the nature, then we would be saying that the nature was real and inverted, but here we will not copy and paste. Okay, we have to apply logic. And what logic I had told you, that if array, check whether array is meeting actually or not. So here you can see the rays are not actually meeting. It is appearing to be coming at this point. It is appearing to be meeting at this point. So that's why here the nature is virtual and erect. Virtual and erect. So this was the case number 6. I hope you got my point. Here you need to be very careful about nature, and size also. Size is highly enlarged, and the position of the image. These cases are very, very important. Okay, these two cases, first this case number 6, and this case is also very important. This case where the size of the image is same as the size of the object. Okay, now let's move on to the next slide. And here in this slide We will simply see what we had seen in sixth cases. Okay, so to memorize or for your simplicity, I had made this table and you can simply before the exam just to look at this table, and if you have a clear idea about the ray diagrams, then your question will not be wrong. So this was the first case when we had placed the object at infinity. So where is the image formed? At focus f2. Okay, and this is the size of the object, sorry, this is the size of the image, and size of the image was highly diminished or point size. Now, what was the nature of the image? Real and inverted. This is the second case where we had placed the object beyond 2f1. Okay, now in that case, what was the position of the image between f2 and 2f2? What was the size? Diminished. And what is the nature in this case? Real and inverted. Okay, I hope you got my point. Real and inverted, highly diminished, and between f2 and 2f2. Now, let's see the case number third. Sorry, this was the case number third when we had placed the object at 2f1. Now, in this case, the position of the image is at 2f2, and the size, if I talk about size, then the size is same, and if I talk about the nature, then the nature is real and inverted, because in these five cases, all these five cases, the image nature is real and inverted because rays are actually meeting. But this last case, case number 6, is the only case where the rays are not actually meeting, they are appearing to be meeting. That's why the nature is virtual and erect. Now let's talk about the case number 4th. The case number 4th. So in this case, what we had done, we had placed the object between f1 and 2f1. So in this case, the position of the image beyond 2f2 and the size of the image is enlarged, and it is also real and inverted. Now, the case number 5th was when we had placed the object at focus f1. In this case, our image was being formed at infinity, and the image, the size of the image was highly enlarged, and the nature was real and inverted. Okay, now this is the last case, last and important case, when we place the object between focus f1 and optical center. We had brought the object so closer to the mirror. Now the position of the image was on the same side of the lens as the object, and enlarged, the size of the image was enlarged, and the nature was virtual and erect, because in this case I have been telling the same thing again and again, and this is important case. In this case, the image was virtual and erect. So I hope guys you understand this topic, and it is very very important, and I hope that it will be a little bit easier to you. It has been little bit easier to you because in when we were discussing mirrors, then we saw all these things at that time also, and here you can say that we are doing our revision. So let's move on. Okay, guys, so here I'm ending this lecture, and we will meet another lecture. Bye bye.